with Sara and Sean.
Hey everyone, welcome to Graph Time. I'm Sara.
And I'm Sean. Sara and I make animations, games, interactions, and we do it all using math in the Desmos graphing calculator.
And one surprising thing that we can do with the graphing calculator, which we actually do a lot, is make animations. And a lot of the time, they don't look like graphs at all. So we're just going to jump right into it. And Sean's going to take us through some of the foundations of how we build animation.
Yeah, so we have a team that makes these different animations and interactions for different lessons. And one of the things we found to be really useful as we kind of like learned to work together was making what we call like animation timers. As you might notice, I already have a thing, preloaded in here. This is something that you'll see in many of the graphs that we make. And it's not really like that complicated. It's not super long. You can have expressions that are way more crazy than that. You might not understand what it does, but I'm just saying it's like not too much stuff. But it basically what it does is just allows you to think of your animations and your timing separately from like what's actually happening on the screen. And we'll show you what that means kind of through the course of this video. But we're gonna make a little animation. We're gonna use this function. And so just as kind of like a little bit of an introduction to what this function is and what it lets you do, basically you would use it by you'd say animate and then write two numbers and your time variable into these spots. This first number is just when you want this one animation to start. And this second one kind of went back and forth about what this should be, but we landed on duration. This is how long it's going to run for. This timer is going to start at 0 and it's going to go for 2 seconds. And we'll make a variable called time. So one of the really nice things about the animation timers is it just lets us have like a lot of different animations happening that are all controlled by one variable, which time is the most sensible thing to name that. Okay, so we can actually visualize what these timers do by just kind of putting an X here to turn it into a graph. So you can see what happens when we graph this function. So, if time were to be negative, like back here, like our animation timer is 0. And then at 0, it starts getting bigger. Like when time hits 0, which is this first number, it starts getting bigger.
Oh, yeah. Oh, time. Okay. Can you label the X? Right now, the X-axis are time, right?
Yeah. So this is time. And this is, I like to think of it as percent, really. Because what the animation timer does for you is it says it's basically going from 0 to 1. So you can think of it like what percent of your animation is done. Halfway through, we want to be like at 50% or 0.5. So I don't, maybe proportion is like the right word to use, but I feel like percent is like helpful. It's just like what I think of, even though it might not be exactly technically correct. So our animation starts at 0 and it goes for 2 seconds. And after 2 seconds, we end up at 1. And the animation timer always ends at 1 because we've just set it up to do that. So
you're saying if you replace that 2 with like a 3, it's still going to end at 1.
Yeah, so we can think about what's going to happen. So if I change this 2 to a 3, it's going to make this animation happen for 3 seconds. So, but it still only goes to 1, like, which is, I think of as like 100%, right? Like, so it's going to be 100% done the animation at 3 seconds and it's going to stay there. But
what if you change that first number?
I was going to do that. What if I change the first number? Well, what's going to happen to the graph? If I change this to a 1, if you're watching, try to think about what would happen. If I change this to a 1, we haven't done it yet. So it'd be pretty cool if you could predict, but.
Well, you said it's the time it starts. And I'm thinking about that as a time that my slope starts moving up. So I think that diagonal line, instead of starting at time 0, it's going to start at time 1.
Nice. And yeah, so if I put a 1 here, it's just going to shift it over. It's going to start at time 1. Now, a thing to notice is it actually goes to 4. And that's because this 3 here, like it's not going from 1 to 3. It's starting at 1 and it's going for 3 seconds. Okay, so we're just looking at graphs. Let's look at something more fun. I'm going to remove all of these things and we'll just see how this actually works. And turn this off. So we need something to animate. Now, I feel like when I started graphing, I would always try to graph every object. But a thing about our work is we have to make sure that it runs on slow computers. And in order to make things run on slow computers, images are pretty much the fastest thing that you can put in here. And also you can make them look a lot nicer. You can have an illustrator like do all kinds of fun things with them. So I'm just importing this image of the blob. Maybe you think that's cheating, but I think it's delightful and fun. So we're going to do it. So we have this blob and we can have, I'll just make them one by one and we can say like P blob. I'm just going to name where the position of the blob. So just put it at the center there. So, okay, my blob's at 0, 0. I could move it around. We want to just animate him across the screen. Let's say I want it to start on the left side of the screen and move it across.
Okay, so it's starting at -3. That's its X position. And maybe we want to add 6 or some amount to the X position.
Yeah, exactly. So if I just write -3 plus 6, now you might be like, well,
It teleported.
yeah, it just moved over there. That's because, the calculator is just doing -3 plus 6, which is 3. So just putting it 3. But I wanted to write it that way because we want them to be separate. Like this is where it starts and this is how much it's moving. But here's where the animation timers come into play. If I give this a name, I say like a move and I make it based on time instead of X. Now when time moves, the animation timer is going to move. So if I just take this a move and I multiply it by this 6, what's going to happen is it's going to move 6 distance. So from here to here is like 6 distance. It's going to move 6 over the course of that animation. So let's see what happens. Press play. Whoop. All right, we did it. I moved across the screen. But I feel bored waiting that first second. So I'm going to go ahead and start it back at 0. I want it to act right away.
That's much better.
Nice. Okay, cool. So we did it. If you wanted to do just that, there's easier ways to do it. You don't need the whole animation timer. But if you want to add in like more phases of animation or more characters and a bunch of things, and you want to like talk about like when this happens and when that happens and all this stuff, then it's very helpful to have the animation timers. But,
yeah, like what if I wanted to make it move across the screen and then up?
Yeah, right. So we have our like X position here and we have our Y position here. So if we wanted to move up at some point, we could make another animation timer. So maybe like a move 2. And let's start this at a different time. So let's start this at like time 2 and just move it for maybe 2 seconds. So start at time 2, go for 2 seconds. All right. Let's see what happens. Now we also over here want to put like how far it's going to move. And kind of one of the nice things about animation timers is we're like separating the math of how far it moves from like what time it moves. And that can be really helpful if you want to tweak an animation. I want this to go a little faster, but I don't want it to go less far. So maybe we'll move it up to, and we'll move it up to along that animation timer.
I like when you have the 0 plus. It's nice to see. We're
Like
starting
this?
at 0, yeah, and we're gonna move. Even though that 2a move 2 is 0, this is kind of nice to see what's going on.
Yeah, I mean, maybe we even do want to move it down a little bit, so there's sort of more room for it to move. One animation timer starts at 0 and goes for 3 seconds. Another animation timer starts at 2 and goes for 2 seconds. What do we think is going to happen?
So something I'm noticing is that a move 2 starts before a move is done.
Yeah.
So there's going to be a point where both of them are going at the same time, where it's going to be moving to the right and it's going to be moving up. Just for 1 second, both things are going to happen.
Let's see. Nice. Yeah, so when we told it to move up and to the right, it started moving diagonally, and then it moved up. Nice.
Cute.
Yeah, you can make animation timers do a lot of things. Another fun thing, I'm feeling like I want to feel like this blob is moving a little bit more. So I kind of want Sarah,
I can make it
really
roll.
excited.
I can make it roll.
Yeah, let's make it roll. Let's get this blob rolling. if we want to make it roll, like spin, we're going to need an angle on our blob. Okay. So we could just make a move be the angle and see what happens. Whoa. Okay.
That was
That is not what I.
interesting.
that is not what I wanted to happen.
It kind
But
of looks like it was like kicked in with some backspin or something. That's not what we want.
yeah, I wanted it to roll kind of with the motion.
Yeah.
It's just the wrong direction, and if we want to change the direction of something, a lot of times we just throw a negative in there. That'll work. I also wanted to spin it a little bit more. It was just kind of felt like it was like falling over, but I want this to move. And since this is an angle, by default, we're going to use radians here. And if you don't know what those are, it's not that big a deal. If we type a number in here, we can see how much it turns. Ooh, 9 feels like kind of right. Like as far, it's like feels pretty close to.
It does feel pretty close, but not
But
quite.
yeah. And then it also is kind of like weird at the end here.
Yeah.
I actually might stop this vertical movement for a
Yeah, I think
moment
that's good.
so that we're just rolling across the screen because that makes more sense. There we go.
So
Okay,
how can
so
we get it to end in the same position if I wanted to do like one full circle over the
yeah,
course of the animation timer?
yeah, at the end here, I definitely want it to not be upside down. So that has so in order to do that, we just have to know how much like a full rotation is in radians, and I just happen to know that it's 2 pi. And maybe I might even go 4 pi here just to make it go a little faster. Like 4 pi is twice as much 2 pi, so should just move a bit faster. All right, there we go.
That was really good.
Yeah, so that's gonna start up rate and end up rate. And I mean, like even if you didn't know, I happen to know this fact about 2 pi. You just type decimals in here until it does what you want it to do, and you would discover pi or 2 pi or 4 pi by doing that. As it
You'd be
turns
a
out.
real mathematician.
Yeah, and if you wanted to be like really perfect, you'd just be getting closer and closer to that number, which is like I don't know, 12-ish, right? Okay, nice. All right, I want to try something a little more complicated here. I feel like maybe just make the blob fall a little bit.
Yeah, let's bring in a background. Let's bring in a course.
I can make a little background here. I have a little cheat code that I type in to give me a square. You can just make a polygon with points, and so these lay out a certain point, make it whatever I want. But let's make like some grass. So grass is green, and I don't need the line, and I can just scale it to make it wider. Can move it to the left. Okay, and then make it a little bit taller by changing the Y's. And then subtract from the Y's to move it down. All right, so we've got a little platform for our blob.
Oh yeah.
I can shift click here to change the opacity. Okay, so I want the blob to be a little bit higher.
I think you should make one more polygon of Earth so that the blob doesn't roll into.
Oh yeah, we don't want to send it into the abyss. So I'll paste another one. Good call. Poor Blobbert. We don't want to hurt Blobbert.
Very precise math I see you doing.
Yeah. This is the process. We type numbers till it works.
Incredible.
Okay, wait, hold on. Now I'm feeling a little like a perfectionist.
You're gonna make a sky.
Yeah, I want to make the sky as well. Oh, we need colors again. We need colors.
No, it's okay. Again. Well, I'm gonna cheat and use the eyedropper and give you a very specific color.
All right.
All right, are you ready? It's RGB. 160. I know. It's just
the superior color scheme.
No. 165, 255, 255. I should have guessed. Beautiful. I should have tried to match our background color via guessing.
Yeah, I feel like you should have guessed. Okay, I just want this to be like the entire background. So I can just make this like 200 and 200. And then surely it'll fill up the whole screen. Oh, one problem is our image went into the background. Images by default go behind graphed objects. If you shift click here, you can turn that off. So now he is no longer in the background.
Okay, this is amazing. All of a sudden, we have a game type looking thing. Yeah. Yes, let's make Blobbert go.
All right, we roll and we don't fall. So first of all, if we want it to fall, we have to figure out when it's going to fall. So we're going to need an animation timer for when it falls, but I don't know when that's happening. But what I can actually do is just move the time to when I think it should start, like maybe here, and see what time it is. So time is 0.82. So I can just say start falling at 0.82. And
You're missing something important.
oh, I am missing something important. We need the animate function. Okay. All right. Okay, so we want to start at 0.82. And then we want like a time that feels reasonable for falling. Now, another fact I just like happen to know, you could try anything you want. I would probably, if I didn't know better, put a 1 here, but I do know that falling happens very fast. So I'm going to start with maybe like a 0 point. I'm going to go crazy and start with 0.4.
Sure.
So that's just a guess. We'll see how it goes, and we'll tweak that later. And then we always want to put time here at the end of the animation timer. So what we want to do is we want to go back to the position of the blob, and we're going to just subtract stuff until it gets to where we want. So I still want the 0.42 here. Yeah, that was luck. I still want that 0.42 here because that's like it being on the platform. But I want to see where it's going to land. So maybe like 1. Oh, that was actually really good.
Yeah, why
1.9.
was 2 perfect?
So, but I only want this to happen when it's falling. So that's where I use the animation timer. Okay. And so I'm going to move. I'm going to fall for 0.4 seconds. Let's see how it looks and tweak it if we need to. So roll, fall, and then, oh, it's kind of like going into the air. Maybe 2. I should have gone with 2 the whole time. Yeah. This image rolls a little funny, I think, because there's like a little
it's not exactly
space,
centered.
but I sort of like how it rolls funny. That's bringing me delight. Blobbert's a little lumpy. I think that might be how they roll. The thing about the falling didn't look right to me. Like it looks like it starts too fast and it ends too slow, and that's because when things fall, they speed up as they fall.
Yeah, like gravity.
Basically, what we want to do is apply something to this animation timer that will start slowly and then speed up over time. And a function that I happen to know does that is squared. So if you think about a squared function, you usually think it goes really fast. Sometimes you might not realize it actually starts kind of slow right at the beginning. So if a neat thing you can do with animation timers is you can just put a function on them and it changes them in a way you might want. So if I just put squared on the falling animation timer, what's going to happen, because it goes from 0 to 1, it's going to start slowly at 0, and then it's going to be going pretty fast at 1. So let's see what it does. Yeah, that feels
way
more real. Yeah. That kind of just feels right.
Yeah, I love it.
All right, so we went through a lot of stuff really quickly. Feel free to pause, go back, take some time, see if you can figure out how to do it. But yeah, we'll post a link that has this animation timer in it, but you could just type it, but so you can kind of start with this. We really have found it just incredibly useful to use this, because if you want to go back and say like, oh, I want this whole animation to be a little bit slower. When we first started making animations, what would happen is like the distance of everything would change, and it would be really hard to like go into the math of every single little different thing and change different numbers everywhere. So this has really organized us and just like made things a little bit easier to think about. Like we don't really have to think about the math of how it works while we're doing it, even though we do, probably somewhere know how it works.
This was really awesome. I feel like one thing I learned about animation timers through like watching you do this and through my experience with them is it's so powerful to have things go between 0 and 1 and like think about things as percentages. And that's a theme that we'll definitely continue to see as we do more animating, which I'm so excited for us to keep doing some animating together.
Yeah. If you're like itching to like go and animate a crazy theme, we're definitely gonna do that. We just wanted to have something to send people back to have like, oh, like here are the basics, like here's how it works. But we go crazy with this stuff. We'll like stack animation timers on each other and all sorts, or like animate a whole scene of different things all at once. So yeah, we'll make some videos of that in the future. So look forward to them.
Yeah, and I'm so glad you made it to the end of this video. We're so excited to make more things with you, and we will see you next time.
Graph time, laugh time, math time, graph time. Let's get creative and play with some graphs. Come round the table and we'll do the math. Graph time! With Sara and Sean.